Imagine spending hours debugging a front-end application only to discover the real culprit was a confusing this binding in an old JavaScript event handler. If you've ever inherited legacy code that's riddled with verbose functions, awkward workarounds, or mysterious bugs when handling user interactions, you're not alone. But what if you could refactor all of that into cleaner, more readable code, making your applications both easier to maintain and more robust? That's precisely what you'll unlock today by mastering JavaScript arrow functions for event handlers. In this tutorial, you'll discover how to spot legacy patterns that slow you down, learn the modern arrow function syntax that eliminates common this headaches, and see exactly how these upgrades will streamline your workflow across plain JavaScript and popular frameworks like React. You'll walk away knowing how to refactor complex event-driven logic with confidence, improve code maintainability, and align your skills with current best practices. If you're interested in writing faster, safer front-end code and want to keep your skills sharp as the JavaScript ecosystem evolves, make sure you subscribe now. That way, you'll always have access to the latest tutorials, expert insights, and practical guides designed to help you stay ahead in your front-end career. The demonstration begins with a scroll to the section comparing legacy event handler syntax and modern arrow function syntax. In this segment, the user interacts with three different counters. The first is a legacy counter, which is clicked twice, incrementing its value and visually updating its count. Next, the arrow counter is clicked 3 times, each click incrementing and displaying the updated count, showcasing the concise and reliable behavior of arrow functions in event handlers. The inline arrow counter is clicked once, demonstrating how inline arrow functions can handle events directly within the JSX or UI markup with immediate feedback. Next, attention shifts to the DOM-based examples. Two buttons are presented, one using a legacy function expression as its event handler, and the other utilizing an arrow function. The legacy DOM button is clicked once, resulting in its display updating to reflect the click count. The arrow DOM button is clicked twice, with each click updating its label and count, emphasizing the streamlined state management and lexical this binding enabled by arrow functions compared to older patterns. The demonstration then transitions to a section focused on performance and handler stability. After scrolling, two more counters are presented: stable handler counter and inline handler counter. The stable handler is clicked twice, reliably incrementing and displaying its count. The inline handler is clicked once, updating its count. A callback counter is also interacted with, clicked twice, demonstrating how memoized arrow functions or hooks like use callback in React ensure stable handler references and optimal re-render behavior. Then, a re-render button is clicked twice to trigger UI updates, highlighting the difference between handler stability and inline handler recreation, which can impact performance in real applications. The next part visualizes the concept of this binding through animated event handlers. Three animated boxes are presented, one representing a legacy handler, one using an arrow function, and one intentionally broken. Each box is clicked in turn. The legacy box animates to show how this is handled traditionally. The arrow function box animates, illustrating the correct lexical binding of this. The broken box, when clicked, displays an error message or visual cue, emphasizing what goes wrong when this is lost or incorrectly bound, providing an immediate visual understanding of this critical difference. The walkthrough proceeds to the section dedicated to edge cases and common pitfalls. Here, a button labeled Show obj.getValue is clicked, revealing that using arrow functions as object methods leads to this being undefined or unexpected. Another button, Try Arguments in Arrow, demonstrates what happens when attempting to access the arguments object inside an arrow function, resulting in a reference error and an on-screen message highlighting the absence of the arguments object in arrow functions. Finally, clicking the new arrow button attempts to use an arrow function as a constructor, displaying a type error and reinforcing that arrow functions cannot be used as constructors. In the next section, best practices for arrow functions are showcased. The user scrolls to see a list of tips and recommendations for using arrow functions effectively in event handlers, including when to use them, performance considerations, and how to avoid common mistakes. The section provides a concise summary of guidelines for writing cleaner, more maintainable code using modern JavaScript syntax. The final hands-on segment features real-world refactoring cases. First, two widget demo buttons are presented. The legacy widget demo button is clicked twice, incrementing and updating its counter label using the legacy pattern. The refactored widget demo button is clicked 3 times, each click updating its label, illustrating the improved clarity and maintainability offered by arrow function-based event handlers. Next, two React components are demonstrated. React legacy counter is clicked twice, each click incrementing the count via the older pattern, while React arrow counter is also clicked twice, highlighting the concise syntax and elimination of manual binding brought by arrow functions in class fields. The effects of each click are immediately visible, reinforcing the practical benefits of refactoring to arrow functions. The demonstration concludes with a scroll to the footer, where a final tip or summary is displayed, distilling the key lessons about arrow functions in event handler refactoring for cleaner, more modern front-end code. In this example, we refactor a legacy class-based React event handler to use modern arrow function syntax. The file demonstrates both the old and new approaches, clearly highlighting the benefits of lexical, this binding, and cleaner code for maintainability. The legacy counter class uses constructor binding for its event handler, while refactored counter leverages an arrow function as a class field. This eliminates the need for manual binding and makes the component easier to read and extend. The exported app function renders both counters side by side, allowing a direct comparison of behavior and code style. This utility file provides a generic debounce function using arrow function syntax for both the returned handler and the internal logic. Such a utility is commonly used to optimize event handler performance, ensuring that a function is not called too frequently in response to rapid-fire events. The debounce utility can be imported and applied to event handlers in the main application code for scenarios like search input, window resizing, or scroll events. The configuration file for the project, package.json, defines the basic project metadata and dependencies. It includes essential scripts to start and test the application. This example ensures compatibility with modern JavaScript features and provides a foundation for integrating build tools and testing frameworks. Arrow functions in JavaScript revolutionize how developers write functions, especially in the context of event handlers. Imagine a world before arrow functions. A developer needed to be vigilant about the meaning of this, often resorting to verbose patterns to ensure the correct context. In legacy code, event handlers were commonly written using standard function expressions. For instance, when attaching a click event handler to a button, the handler's this is set to the button element by default. However, when such handlers appeared inside constructor functions or class methods, developers encountered the notorious this binding problem. To work around it, they often employed techniques like assigning var self, this, or explicitly binding functions with bind this. These patterns not only cluttered the code, but also increased the likelihood of subtle bugs, especially as code bases grew. Arrow functions elegantly solve this problem by capturing this from their surrounding lexical scope. Unlike traditional functions, arrow functions do not define their own this at all. They inherit it from where they are defined, not from how they are invoked. This means that when you write an event handler as an arrow function inside a class method or constructor, this will always refer to the instance you expect. The result is code that is shorter, easier to read, and far less error-prone. For example, instead of writing element.add event listener, click function event, self-handle click event. You can simply use element add event listener click event this handle click event and be confident that this points to your class instance. The difference is analogous to using a walkie-talkie versus a landline. With a landline traditional function, your connection depends on where you call from. With a walkie-talkie arrow function, you always keep the same channel, no matter where you are. This predictability is invaluable in modern front-end development, where components, closures, and asynchronous code intermingle. By adopting arrow functions for event handlers, developers declutter their code, reduce cognitive overhead, and pave the way for a more maintainable and robust application architecture. Refactoring legacy event handlers to arrow function syntax is more than a syntactic update. It's a strategic move toward cleaner, more maintainable code. Consider the maintainability of a codebase as a garden. Legacy patterns, such as anonymous function expressions with manual this binding, act like weeds. They make the garden harder to navigate, especially for new gardeners who must learn to distinguish between intentional plantings and accidental growths. When you refactor event handlers to use arrow functions, you remove these weeds. The code becomes more intentional and expressive. Take, for example, a class managing a UI widget. In the old pattern, you might see var self, source this, or this method bind this, scattered throughout the code. Each instance is a potential stumbling block for future maintainers. By transitioning to arrow functions, you centralize the management of this, making the code's intentions explicit and reducing the risk of bugs introduced through incorrect bindings. Beyond clarity, arrow functions enable the leveraging of modern JavaScript tooling. Linters, formatters, and static analyzers are optimized for ES6 plus syntax, providing better feedback and automations when arrow functions are used. Furthermore, frameworks like React and Vue embrace arrow functions in their idiomatic usage. React class fields, for example, allow for concise event handler definitions that are automatically bound. This convergence of syntax and tooling leads to more consistent code bases, smoother onboarding for new developers, and a reduction in technical debt. Refactoring is not just about changing how code looks, it's about improving the developer experience. A code base written with clear, modern patterns invites collaboration, eases testing, and stands the test of time. Arrow functions, by eliminating boilerplate and making the flow of this transparent, transform a tangled thicket of event handlers into a well-tended, thriving garden, ready to support the next wave of features and contributors. Refactoring your legacy event handlers with modern JavaScript arrow functions isn't just about writing cleaner code. It directly impacts your productivity, your codebase's maintainability, and your confidence as a developer. With the insights and real-world strategies you've seen today, you're now equipped to eliminate those old, error-prone patterns and replace them with robust, future-proof solutions that work seamlessly across frameworks and tools. Every time you modernize a handler or streamline a callback, you're saving future hours of debugging and making your team's life easier. If you want to keep accelerating your JavaScript mastery and always have practical, up-to-date examples at your fingertips, make sure you subscribe. That way, every new technique and best practice lands right where you need it, on your screen, ready to use in your next project.